Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll discuss about question number 18 of NEET physics paper 2015. Students, let us solve question number 18. A mass M moves in a circle. This is a mass moving in a circle on a smooth horizontal plane so there is no friction. So let us suppose that this is the table or any surface, horizontal, smooth. So its mu value is 0, no friction. And so moving in a circle. Moving in a circle, this is the mass supposed to be here anywhere. It's moving with a velocity v naught. And this is the center. And this radius is r naught. Speed is v naught. The mass is attached to a string. So this mass is attached to a string. This is the mass attached to a string which passes through a small hole in the plane or ozone. Ozone means from the center there is a hole on the surface, and through which a thread goes down. So it is surface. This is a string goes. This is a string. The bob rotates or mass or rotates. So as we are just rotating the mass. So mass is rotating, and there is a string which holds the mass from moving away. If I hold it tight, then the mass is supposed to move in that circle. The tension in the string is increased gradually. So tension is increased gradually means I increase the speed. Tension is increased gradually, and finally moves in a circle of radius r by 2. So it says that if tension increases, then radius decreases to half its value. Now the new radius is supposed to be this, which is r naught by 2. R naught by 2. The final value of kinetic energy. So in this situation, what is the kinetic energy? In the final case, what is the kinetic energy in the initial case? Initial case, the kinetic energy is half m v naught square. What about the final kinetic energy? That we have to find. Firstly, that the particle is moving in a circle. For any circular motion, centripetal force has to be provided from outside. So here the mass m is moving in a circle, and who provides centripetal force? It is the tension in the string. So the tension in the string has to provide centripetal force. So therefore this tension is always directed toward the center. So this is the tension, and that tension provides centripetal force, and because of that it is moving. If tension provides centripetal force, then we know that formula for centripetal force is given by formula for centripetal force. The centripetal force is given by, suppose that Fc is standing for centripetal force, then centripetal force is m omega square r, or m v square, that is v naught square by r naught. Here r, I'll write m omega square r naught. In this present situation, this is the centripetal force at the initial case when the particle is maintaining moving with v naught mass m and radius is r naught. In that situation, the centripetal force acting is m v naught square divided by r at that particular instant. This is the center. Now you can see here that if I can relate this with this, And who provides this? Tension. So tension is mv naught square divided by r naught. Or I write m omega square r naught. Initially whatever is the omega, that omega is here. I can write this as also omega naught square if it is the initial situation. Now if this increases, what will happen? It says that as tension increases, r the radius decreases to how much? R naught by 2. From r naught to r naught by 2. If this has to decrease, m will never change. This is decreasing and this is increasing, so this has to increase. This has to increase. If this increases, this decreases. So to increase tension, R has to decrease. If I decrease R, then this increases. Okay. So if you have to, as it says that radius is R naught by 2, then how would I solve this question? It is, I will say that I have to apply a principle of conservation of angular momentum. Why I should apply principle of conservation of angular momentum? Because here when the particle is moving in a circle with tension being provided by external agent, the torque about the center of circle is 0, because the forces that is acting, I will neglect the weight gravitational force, but if I do consider the gravitational force, then the normal reaction and the gravitational force being equal will provide no torque about the center of the circle. So, and the tension passes through, the line of action of the tension passes through the origin or center. The line of action of tension passes through this point. So if this point is O, then torque about this point is 0. So since torque about the center of circle is 0, that implies the angular momentum is constant about center. It will remain conserved. If it is conserved, then I will apply conservation of angular momentum. This principle I will apply, conservation of angular momentum. The conservation of angular momentum, the initial angular momentum and the final angular momentum have to be equated. Continuation of so Li is Lf, initial angular momentum is m v naught, speed was v naught, and r naught was radius, because we know that for a particle in a circle of radius, suppose r, moving with the velocity v, mass is m, for any particle in a circular motion, the angular momentum about the center is always mvr. So this is the formula. About the center, it is always mvr. So here it is mv naught r naught. That must match with mv. What will be the v? V will obviously change. I don't know that. Suppose that v is v final. mv r is r naught by 2. So if I use this, then mm cancels and r naught will cancel. So vf, v final is 2 times the v initial. So if I want to, because this mv naught r naught has to be constant, so if this reduces by 2 times, this has to be increased by 2 times, so that they will cancel and it will remain same. So therefore the speed has to be increased by 2 times, that is 2v naught. So if I do that, then once I got the speed at the time when the radius decreases to r naught by 2, the v2 I got v final is 2v naught, then mass is m, then I can obviously write what is the kinetic energy at this situation. The question is to find the kinetic energy. Kinetic energy formula final is half m v final square, which is half m v final is 2v, squaring this is 4v naught square, this is 2, so it is 2m v naught square. This is the answer to this question. So if I see the option, then the final value of kinetic energy is 2 mv naught square. So this is 2 mv naught square. So this is the final answer to this question. Okay, thank you.